Hello everyone. We will have evaluating algebraic expressions. So that would be our objective as well. So in algebraic expression, when a variable is replaced by a number, the algebraic expression takes a numerical value. So what does it mean to evaluate an algebraic expression? So what I've stated a while ago is actually all about evaluating, and the purpose is to find its numerical value given the value of the variable. So let's try some examples. So number one, evaluate 2x squared minus 3x plus 5 if x is equal to negative 2. So here, let's copy the given. So that's 2x squared minus 3x plus 5. Considering that we know that the value of the unknown variable x is a negative 2, what we need to do here is replace x with negative 2. Replacing a variable with a number is also called as substitution. So we substitute negative 2 to x. So when we substitute, you are encouraged to enclose it in a parenthesis to avoid some mistakes in terms of understanding the given. So enclose it in a parenthesis once you replace the x with a negative 2. So take note, you're just simply replacing the x. But regarding the 2 here and the 2 here, which is the exponent, you will not do anything to it. So that's minus 3. There's an x again. So parenthesis, negative 2. Then what do we do right now? So we follow PEMDAS. So when we follow PEMDAS again, it's parenthesis, exponent, multiplication and division from left to right, and then addition and subtraction from left to right. But luckily, since we're already aware of the concept of terms in an algebraic expression, we can make things faster. So this is a minus, this is a plus. So that means that we can just think of our first term separately. So start with what's inside the parenthesis and then get its square. So the square of negative 2, the square of negative 2 means negative 2 times negative 2. So negative 2 times negative 2 is positive 4. So this one becomes positive 4. Let's deal with the second term. Now I know that this is a minus, but we have a rule before that once we have a minus, we just have to change it to addition, but get the opposite of the number on its right. So automatically, we will think of this as plus, but we change the 3 into negative 3. Okay, so still same concept. So this is our first term. So 2 times 4 is 8. Then here, this is our second term. Negative 3 times negative 2 is positive 6. Then 8 plus 6 is 14. Then 14 plus 5 is 19. So the answer is 19. Okay, let's have number 2. X squared minus 3y plus 5 when x is equal to 3 and y is equal to negative 1. So first thing to do, copy the given expression, x squared minus 3y plus 5. Then substitute 3 to x. So don't forget to enclose it with a parenthesis. Then you have the square here. So the x is 3, but the y, so just copy minus 3, but the y is a negative 1. So don't forget to enclose it inside a parenthesis. So this is our first term. This is our second term. This is our third term. So the third term is actually our constant term. And here, we have our coefficient in the variable. So our first term, the square of 3 is just a 9. Here, this is a minus. So in other words, that will become a plus. And the 3 here becomes negative 3. So negative 3 times negative 1 is positive 3. Then you start from left, going to the right because the operation that we have here is just an addition. So 9 plus 3 is a 12. And then 12 plus 5 is 17. So that's our answer, 17. Okay, let's have our third example. Evaluate 4x cubed z minus 9y squared when x is equal to negative 2, y is equal to 1/3, and z is equal to negative 1. So first, just copy the given equation. So we have to find the value, numerical value of this expression by just substituting the values for each variable. So our x, when we try to substitute, don't forget to enclose it inside a parenthesis. Then we still have the cube here. Then the z is negative 1. Still enclose it in a parenthesis. This is a minus 9. Then you have a y already. So the y is 1/3. And don't forget there's still a squared here. The exponent 2. So this is a minus. So perhaps you'll start with the first term. So you follow PEMDAS by getting the cube of negative 2. The cube of negative 2, I'll do it here. It means negative 2 times negative 2 times negative 2. So two numbers at a time. So negative 2 times negative 4 is positive 4. And you still have the other negative 2. So 4 times negative 2, they have different signs. So negative 4 times 2 is 8. So this will give us an 8. A negative 8 rather. Our second term, before it is a minus. So we change the minus into plus. So that the 9 here becomes a negative 9. Okay, now here, 4 times negative 8 is negative 32. Okay, now in our second term, we still have to get the square of 1/3. The square of 1/3 means multiplying 1/3 by itself twice. So the rule in multiplying fractions, numerator times numerator, denominator times denominator. So 1 times 1 is a 1. 3 times 3 is a 9. So this is a 1/9. Now, going back, this is our plus again, so don't forget. That separates the two terms that we're dealing here. Negative 32 times negative 1 They have the same sign, so that will become positive 32. Then don't forget the plus. Then here, negative times positive, because this is a negative 9, this is a positive 1, 9. So, of course, the result would be negative. And then, as you can see, we're multiplying a 9 with a 1 over 9. And from first quarter, we can cancel out the 9. Because the 9 is in the numerator, the 9 is in the denominator. So what is left is just 1. So you have 32 plus negative 1. That would be, they have different signs. So you need to subtract them. 32 minus 1 is 31. And then 32 has a greater absolute value compared to the absolute of negative 1. So positive 31. So that's our answer. Okay, let's continue. Okay, this is a learning tip. So as I said a while ago, to avoid careless mistakes, always use parentheses when multiplication is implied. So just like this, 3x plus 2, the x is negative 4. So when we substitute negative 4 to x, enclose it in a parenthesis. Because if you don't, it will look like this one. You might be thinking of it as 3 minus 4, which will give us another result. So instead of negative 10, you will arrive at an answer which is 1. Because you subtracted 3 and 4 instead of multiplying 3 with a negative 4. Okay, let's have example 4. So evaluate 2 plus the square of m plus 1 plus 5m cubed minus m over 3 when m is equal to negative 3. So how do we find the numerical value of the expression given that m is negative 3? Okay, that's the meaning of the word evaluate. Copy the expression first. So 2 plus m plus 1 quantity squared plus 5m cubed minus m over 3. So don't forget, just copy. Okay, constant term because it's just a 2 plus, meaning there's another term coming. So m, don't forget to enclose it in a parenthesis just to be sure. Plus, meaning this is another term. You have 5, then the m, enclose it in a parenthesis again. M is negative 3. There's a minus again, another term after this. So you have m over 3. So parenthesis, negative 3 over 3. So, this is just a constant, so nothing will happen to it. But here, in our second term, negative 3 plus 1, they have different signs. So subtract 3 minus 1 is a 2. Negative is, the absolute value of negative 3 is greater than the absolute value of a 1. So we copy the sign of the negative 3, which is negative. So don't forget, there's still an exponent 2 outside the parenthesis. Next would be our third term. We start from getting the cube of negative 3, meaning you're multiplying negative 3 times by itself. So negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Then we have the fourth term. Negative 3 divided by 3. They have different signs, so negative. 3 divided by 3 is just 1. So next, this is a constant term. The square of negative 2, meaning negative 2 times negative 2. That's a positive 4. Next would be 5 times negative 27. So they have different signs, so negative. So 27 times 5, 5 times 7 is 35, 5 times 2 is 10, plus 3 is 13. So this is negative 135. This is a minus, so we're changing that to addition, but the negative 1 becomes a positive 1. Then you start from left going to the right because the operation left is just addition. So 2 plus 4 is 6. Okay, 6 plus negative 135. They have different signs. This is positive, this is negative. So in other words, you need to subtract 135 with a 6. So 15, borrow 2 here. Borrow from 3, so becomes a 2. 15 minus 6 is a 9. Then you have 2, then 1. So 129. But take note that the absolute value of negative 135 is greater than a 6. So we follow the sign of negative 135, which is negative. And then finally, we have negative 129 plus 1. They have different signs again. In other words, you need to subtract 129 with 1. So 129 minus 1 is 128. Then copy the sign of the larger absolute value, which is negative 129. So the answer is negative 128. Okay, this would be my last learning tip. So remember that negative 3 squared is not the same as the square of negative 3. So what makes them different? When there is no parenthesis, the base of the exponent 2 here is just the 3. So 3 times 3. Then here, you just copy the negative. 3 times 3 is 9. So the final answer is negative 9. But if you have the square of negative 3, meaning the negative 3 is really enclosed inside the parenthesis, the base of the exponent 2 is really the negative 3. So we're multiplying negative 3 by itself twice. Negative 3 times negative 3 is 9. So learning tip again. This is related to my first learning tip. When evaluating a variable with exponents, always put parentheses when the value to be substituted is negative. Okay, for our example number 5, we have here evaluate 3x plus 2 all over x minus 1 when x is equal to negative 4. So same as before, we just copy first our given expression. So that's 3x plus 2. We say all over because when we say 3x plus 2 over x minus 1, it means that translating it would just be like this. So 3x plus 2 over x minus 1. So when you try to relay a message that all of the terms that you've said first, under it has an x minus 1, so you say all over. So 3x plus 2 all over x minus 1. So same as before, that's a 3. And don't forget, we're replacing x with a negative 4. So we enclose it with a parenthesis, plus 2 all over. Then there's an x again. So negative 4 minus 1. So if it would look like this one, you start by simplifying the parts of the fraction. So you start by simplifying what's in the numerator. So of course, PEMDA says that we multiply first. So you will not add yet. So 3 times negative 4 is negative 12. And in the denominator, we have negative 4 minus 1. So if it's a minus, change it to addition. Then change the 1 to its opposite, so negative 1. Now in the numerator, they have different signs. The operation is addition. So the rule says when they have different signs, we need to subtract. So 12 minus 2 is a 10. Then the absolute value of negative 12 is greater than the absolute value of a 2. So negative 10. Then in the denominator, negative 4 plus negative 1, they have the same signs. So we need to add 4 and 1. 4 plus 1 is 5. And then copy the common sign, which is negative. Now we have negative 10 divided by negative 5. So negative divided by negative is positive. 10 divided by 5 is 2. So our final answer is a 2.